Study of control valve characteristics. This is the fourth experiment. Study of control valve characteristics. Usually there are three types of control valves. One is called a linear valve. Linear valve. Next one is called equal percentage. Equal percentage. The third one is called quick opening. Quick opening. There are three types of valves. One is linear, equal percentage, quick opening. Linear valve means this is opening of the valve 0 to 100%. 0 to lift is in the lift. Lift of the valve is in the x-axis. Flow rate in the y-axis. Flow rate in the y-axis. For linear valve means linear valve. Equal percentage means the characteristics will be like this. Equal percentage. Quick opening means its characteristics will be like this. Quick opening will be like this. This is linear valve. This is linear. Linear characteristics. This is equal percentage. This is quick opening. This is true only when the pressure drop across the valve is constant. Pressure drop across the valve is constant. For that, to understand that how the valve is, this is the valve. To understand this characteristic is called inherent characteristics. Inherent characteristics. After installation, if you see the characteristics, then it is called installed characteristics. You are putting the valve in practice, then if you see the characteristics, then it is called installed characteristics. This is, you are seeing only valve and see the characteristics. This is called inherent characteristics. Before going to this, how a valve looking like that we will see now. Valve means it gives a flow rate. Flow rate is given. This is inlet. This is inlet. This is outlet. A plug will be there. Truncated plug. Because of this truncation, the opening will vary from 0 to 100%. Opening will vary from 0 to 100%. That depends upon the displacement of this stem. This plug will move and will give an opening like that. The flow rate will be going through this. The opening, the flow rate will be in this direction. In this direction. So I will draw this plug alone separately. You can understand. This is 100% open. This is 100% open. 100% open. Another one I am telling. This is 100% closed. 100% closed. 0% open. Here the flow rate will be maximum. The flow rate here will be 0. This part alone I have drawn here. Partial opening means it will be like this. Partial opening means it will be like this. Depends upon the shape of this plug. The characteristics will be like this. All other structures are same. Only that the plug shape modify, you can change the type of flow rate. Linear, equal percentage, or quick opening you can do. Here, now we'll see that here this is fully closed. This is fully open. This is partially open. Inlet flow, this is outlet. The inlet will go through this and go this way, and it will come out through this. We have to move the stem up and down. Depends upon the 3 to 15 psi. To move that, the stem is connected up to this, it will come and it will connect it to a flexible member. I'll draw here. If you see that, it will be very confusing for you. That's why I'll draw the simplest diagram here. This is the stem, the plug is here. This is the this is inlet, input, this is output. Always input is from bottom. It should go against the gravity. To avoid, it should not flow because of gravity. It should not flow because of gravity. That's why that arrangement. It has to flow against gravity. Because of pressure, it has to flow. Okay, input will be in the bottom, output will be in the top. So here, the displacement of pump is how it is done. There will be an opening here. This is flexible member. This is a flexible member. If we give 3 to 15 psi, for 3 psi, 100% open. For 15 psi, completely closed. 15 psi, completely closed. This is the arrangement. The stem will move, depends upon the pressure, 3 to 15 psi. So that is available here. Here, one spring is loaded here. You see that a spring is loaded here because if you remove the pneumatic signal, it should regain to original push. You are giving 15 psi, it is completely closed. If you remove that 15 psi, it should come again to complete open, 3 psi means completely open. 15 psi means completely closed. So after giving 15 psi, if you remove that 15 psi to 3 psi means it should again come to that original position. For that, the spring is loaded. The spring is there. So spring is here. That's all. Here, the casings will be there so that there won't be any leak because this is a moving part. Here, there should not leak. There should not be any leak. That's why casings will be there. These and all you can see in the lab. This is the spring. This is the spring. This is called a stem. Valve stem. This is called a stem. That's all. Now, there are two types of valves. Here, I said, if you give 3 psi, 100% open. If you give 15 psi, completely closed. This is called air to close. Air to close type of valve. Air to close type of valve. Instead of giving the pressure signal here, if you give the pressure signal here, initially it will be completely closed. Initially it will be completely closed. If you, this is air to open. Air to open means air to open. If you give 3 psi, initially it will be completely closed. If you give 3 psi, because we are giving the pressure signal the bottom, that's why it will lift the stem. That's why it will go up. For 3 psi, slightly go up. For 15 psi, completely go up. So that is called air to open. So this difference is that one of the valve is air to open, other two are air to close. I think so. One is different, other two are same. So you can see where the signal, pneumatic signal is given by looking at that. You can understand whether it is air to open or air to close. For air to close means for 15 psi 0. Air to open means for 15 psi completely open. For 15 psi completely open. Another type is air to open, air to close. That is there. So if you want to replace why air to open, air to close, there are two types are there. Means in the industry, sometimes pneumatic signal may failure. Pressure signal has to come from pressure source. That source fails means the valve will fail. Suppose it is air to open. Means pneumatic signal fails means what will happen to the valve? Air to open. Completely closed. If pneumatic signal is not coming means completely closed. So depends upon the safety requirement, they will select either air to open, air to close. If pneumatic signal fails, the valve should be closed or open. Sometimes should be open. If it is water, it should go out. The tank should not overflow. Then the tank, if pneumatic signal fails, it should be open. In that case, air to close. It is an acid, it should not go out. It should be closed, or some other reason it should be closed for safety purpose. When pneumatic signal fails means we have to use air to open. So it depends upon the safety aspect. Either we will use air to open or air to close. That adjustment is there in the controller. Controller, for zero error, it will give 15 psi or 20 milliamps. For zero error, it will give 20 milliamps. For 100% error, it may give 0. Like that, you can reverse the controller output. That provision is available in the controller. That provision is available in the controller. So you can, depends upon the value, you can change there. Or you have to vary 4 to 20 milliamps or 20 milliamps to 4. How you are going to vary, that can be changed there. I understand this point. So it's not possible to complete this in 15 minutes, I know. But anyhow, I want to give introduction about the control valve. The next class, we will complete this experiment. Okay.